Okay, so this is a picture showing both the entity and the attributes. So as review, entities are basically nouns. So people, places, objects, events, concepts, they're represented by that rectangle. So here we have department. The attributes are the aspects of the entities. So these are our fields or columns in a table, and they're represented by ovals. They're usually pretty easy to spot if you have a well-worded business rule like this. So here, there's several departments in the company. So that's the entity. Each department has a unique identification, a name, location of the office, and a particular employee who manages the department. So you have the ID, name, location, and a manager. So that should be fairly easy. The biggest thing to remember here is the differentiation between the rectangles and the ovals, and that each oval just connects to one table because the column belongs to one table. Pretty intuitive. So you should be able to do this yourself now. So we have an example here. Each employee has a name, identification number, address, salary, and birth date. An employee is assigned to one department. So go ahead and give it a try. Pause here if you need a minute. Here you go. You can see that we have ID number, name, address, salary, birthday. Pretty simple. Now, the attributes have several different types. So far, we've had actually a mixture of both simple and composite attributes. So simple attributes are going to be ones that aren't going to be broken down at all. An ID number, for example, is just an ID number. You're not going to break that into different segments. However, some of these can be broken down. Names are a perfect example. You could have a name as one field, of course, but if you split it up into first name, middle initial, last name, that lets you be able to sort things by first name if you needed it, last name if you needed it. You could order it however you needed to. You pull the information different ways. Addresses, usually if you think about a form you fill out, usually they have the street address separated from the city and the zip code and the state. There's a good reason for that, so you could filter by state, for example. You can pull them up in different ways. So you could have one oval that says address, and then you can break that up into smaller pieces. Derived attributes are anything that can be calculated from a related attribute. So you can take a column that says the amount something costs, so the price. You can take the amount that someone ordered, you do math, and then you come up with the total price. You don't need the total price in your database because that's going to change depending on all these different factors, right? So if you just do it as a calculated field, like you would in Excel, then it just makes it simpler. Same thing with something like birthday. You don't have to store somebody's current age. You can calculate it if you know what day they were born. So a stored attribute is the attributes that you actually store. So that'd be the birthday in this example. Then the derived is the actual current age, which is what you're actually interested in later. A single valued attribute is one where there can only be one value. So if you can't enter in multiple things, and usually this is what we want in the long run. So you can be a undergrad or a grad student, for example. Usually you can only put in one gender inside of a field. If you have a multi-valued attribute, that would be something where there's multiple things that are possible. So last week, when we had the example of my D&D nerd example, you can have a multi-class character. You can have someone trained in multiple disciplines, basically. Those of you who aren't nerds like me, you can think of it as like you could have a degree in psychology and then a degree in data science, and you have multiple disciplines, right? You can have multiple language. Someone who is bilingual or trilingual will want to have multiple entries into the same field. Multiple dependents, anything like that. And then lastly, there's identifier attributes. These are super, super, super important, and we're going to get into this into more detail. But things like employee ID numbers, student ID numbers, that's the way that your information is called up. And so that has to be stable. And it's the way that relational databases connect everything together and do all the cool magic. This is what separates us from the other more simple types of data or models, such as the hierarchical and network model. Okay, so let's look at those again a little bit. So for examples, so a simple would be salary. You're not breaking it down. There's not multiple salaries usually, unless you're like a contractor and doing other weird things, but a normal employee only has one salary for a company. Here you can see that example of the name being broken down into other attributes. So you can see that the way it's shown is you have one circle with your main attribute, the composite one, and then you have that splitting out into each separate attribute. Address, you do the same way. A birthday, you could do that too. You could store the month and the day and the year totally separately if you wanted to. But you wouldn't necessarily have to. You can see the derived with this, and I color coded it so you could like find it easily, but you know, if you can do this black and white, you don't need the colors in there. So the dashed outline is what designates a derived value. So age is calculated from the birthday. Multi-valued, and here I have skills as the example, and you'll find that with the double outline. And the ID, we'll get into those later, but usually you'll see an underline on those. So these are the different visual components. So you'll want to look out for those dashed lines, the double lines, and then attributes coming off of other attributes. Now the key identifiers, which is what just referring to 2 seconds ago with the underline. So usually we'll call them keys. You'll hear primary key and foreign key a lot, but you'll also hear identifiers. So all keys are just anything that can identify a row from the other rows. So how are you finding which person filled out the survey or whatever it is? All the keys possible are called candidate keys. So they're all candidates. However, the primary key is the one that we're saying, okay, this is the one that we are going to use to identify the records within this table. So usually it's going to be something that's like actually labeled like ID number, something like that. So like at our school, your student ID number is probably what they use. You'll also see things like social security numbers. Hopefully those are different things. My undergrad back a million years ago, they were not different. My social was on my ID card and it was not good. You can also have things like a generated ID where the database will actually create one, which is a nice way to do it where it's, it's a unique number. But that would be something that's platform specific, whether it can do that or not. Generally, we have a list of short best practices here. We want it to be like long enough that's going to be unique, but short enough that you can actually enter it. Like you don't want a 24-digit ID, ideally. It's best if it's numeric only. The reason for that is because it's going to take less processing power for your computer to run. And this doesn't matter in a small database like what we're going to do as practice for this class. But if you're thinking about a database for something like Amazon, every little bit like that actually does matter. For the same reasons, we want it to be simple. So no weird characters, not like a password. We don't want any spaces in it. We want it to just be straight up numbers across. And it has to be something that's stable, cannot change. So this is why things like social security numbers actually aren't necessarily the best, because those can change for people. Usually it's fine, but it is better if you can have an internal type of ID that you know will not change. So when you're looking at the attributes, those are going to be underlined to show that it is the primary key. A few more things about attributes, and I did mention the word foreign key. We will circle back around to that. So other little things to know about attributes before we move on. So the terms domain, so those are all the possible legal values for an attribute. So if it's like a list of genders, for example, things like this are important to think about, because like an older company might only allow you to select male or female. And that means that anyone who identifies as non-binary or anything else is forced into selecting one of those, which is not ideal. So when we're defining the domain of possible values, those are things to think about. Another easy example is folks that have double-barreled last names like I do, which is really common in certain cultures, where they'll have multiple last names that they might use selectively, or a longer last name like I do, where there's spaces instead of hyphens. Sometimes you can't enter those, that the computer will reject the space. So either I have to select a piece of my name, or I have to misspell it by putting a hyphen, because somebody decided that that is not a valid domain, even though it's legally my name. So these are really important things to think about, and especially thinking about if it's not a business rule, if it's like an identity issue, thinking about other cultures other than your own, and what are common issues like that come up for people. Null values, on the other hand, is when an entity instance lacks a value for that attribute. So can, in a certain record, can it be null, which is different than saying 0. And we'll get more into that when we're talking about, well, next week, when we're going a little bit deeper on things. But these are key terms to keep in the back of your head that we will have to define a little bit more when we're in the more SQL-y side of this project in class.